Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we are doing IXL E7, which is finding the distance between a point and a line. So these problems are going to start out kind of simple, and we'll use a graph to solve them. And then they're going to get a little more complicated as we get higher. So each problem is going to give you an equation of a line, and then also a separate point. So this problem is saying that we have a line L, and the equation for that line is y equals 1. Find the distance between line L and the point -6, comma -1. So I have a handy graph right here that we can use. And what we're going to do is draw the line first, and the line is y equals 1. So remember, whenever we have a equation like that, all the way back to transformations, that's just indicating on the y-axis, it is going to go through 1. So we go to the y-axis, 1 is right here on the y-axis, and our line, hold on. Okay, and the line is going to go straight through this point. Kind of like that. Okay. And then we're going to draw our point. Our point is -6 and -1. So we'll come over here and we have -6 and -1. So here. And so what is the distance between this point and this line? 1, 2. Just 2, and that's it. Okay, it's as easy as that. Distance is 2. Cool. Okay. Let us skip another level. Same problem there. Skip another level. Not quite there. Let's do one more down here. Okay, fine. So we'll come back up. We'll erase this line. And same type of problem. We have the line y equals 4, and then the point 4, comma 0. So we'll draw the line y equals 4 is just where 4 is on the y-axis, so which is right here, and we're going to draw that. And then with the point 4, comma 0, which is right here. And the distance between this point and this line is just 1, 2, 3, 4. It's just 4 units away, right? So type in 4, and that is correct. Okay. Same type of problem here. X equals -1. It's just where -1 is on the x-axis. You do the point. Okay, so I'm going to skip up to 65. And that's a decent one with y equals x, but I'm going to actually do another one instead. We'll go over, these are all y equals x. Okay. Y equals x is not as bad as some of the ones you might see, so I want to make sure you get to see how to do the other ones. Okay, here's one. So this time, instead of giving you a basic equation like y equals -1 or x equals 4, they're going to give you something that resembles closer to the point slope, or not the point slope, the slope-intercept form. And so they're going to give you that, and they're going to give you a point like always. So we will draw this. Okay, and the equation is going to be y equals x minus 3. So I'll draw that. Yeah, we'll do it right here. Y equals x minus 3. And the point was going to be, I think it was -3, comma 7. Is that correct? Yes. Okay. So work our way from there. So let me plot the point first, and the point is -3, comma 7. So -3, comma 7. So it'll be right here. And now let's plot the line. So we know -3 is the y-intercept, so that's where it intersects on the y-axis. So we'll go down to -3 right here. That'll be our first point to the line, and then we will look at the slope. So the equation is y equals x minus 3. The number in front of the x is m, which is the slope. Since you do not see a number there, that just means it's 1, because 1x is the same as just x. So m equals 1. equals 1. And it might be easier to think of that in terms of a fraction, so 1 over 1. It's the same as 1. Okay, and that way we know we have a rise over run or a change in y over change in x. So it's just going to change by 1 in the positive x direction and 1 in the positive y direction. So we'll start here at our y-intercept and go up 1 and then to the right 1. Up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1, etc., etc. So the line is going to look something like this. And again, I'm going to do a very, very rough estimate here. Okay. And so we want to find the distance between this point and the line. Now, the problem is the closest distance between the point and this line is not vertical or horizontal. It's not perfectly up and down or perfectly left to right. It's kind of slanted, right? It's diagonal. So we are going to have to use the distance formula. Okay, and the distance formula is going to be d equals the square root of x2 minus x1 all squared plus y2 minus y1 squared. Okay. But we need two different points to plug into here. We only have one right now, which is negative 3, 7. So we have to come up with a different point. So we're going to go back to what we did a couple IXLs ago. And we already have a line here with this equation, y equals x minus 3. And you see a line here, the line we kind of made between the point and the line, is going to be another line. In fact, it's going to be a perpendicular line to our original line. Okay, and we can use that information alone to basically come up with our second equation of the line and therefore our points. So we're going to come up with an equation for this perpendicular line right here first. And so it's going to be y equals mx plus b. We're going to start with that. Okay, and remember, we just need to find m and b. So m is the slope, and what do we know about the slope of two perpendicular lines? Well, they're going to be opposite reciprocals, right? Remember that. So since we know the slope of our first line here is just 1, that means the opposite reciprocal of 1, or 1 over 1, is going to be negative 1 over 1, or just negative 1. Meaning our equation is going to become y equals negative 1x plus b. And you don't have to write the 1 there, right? Okay, so we're almost there. And now what we're going to do is we're going to grab the other point, and we're going to plug it in. So we're going to grab negative 3, 7 and go 7 equals negative 1 times negative 3 plus b. Okay. And then we'll do 7 equals 3 plus b. And therefore, b is going to equal 4. Meaning our equation up here is going to be y equals negative x plus 4. So we have our equation. We have our two equations. Great. That's wonderful. So now what we're going to do to find our second point, so we can plug it into the distance formula, is we're going to set this equation right here equal to our equation of the other line, the first equation we got. Meaning we are going to basically plug this side in, so x minus 3, we're going to plug that in for y over here, because y equals x minus 3, and therefore x minus 3 should be able to plug into y. So we'll do x minus 3 equals negative x plus 4. Okay. And then we'll just get x by itself. So we'll add x to both sides. Like that. Okay. And cross those out. So we're left with 2x minus 3 equals 4. Okay, add 3 to both sides. Get rid of that. So we're left with 2x equals 7. So x is going to equal 7 over 2, which is just 3.5. Okay, so that's going to be x, and now we need a y coordinate. So all we're going to do is plug this into our equation. Just you can plug it back to either one. We'll just plug it into this one right here to get y. So now we're going to do y equals negative x, and the x we just figured out was 3.5, so 3.5 plus 4. So y is going to equal minus or negative 3.5 plus 4 is now positive 0.5, or 1 over 2, whatever you want to write. Okay, so now we have our x coordinate and our y coordinate. So we have our point. Our second point is going to be 3.5 comma 0.5. And our first one, of course, is going to be negative 3 comma 7. And that's from the information they gave us. So these are the 2 points we're going to plug in to our distance formula up here. So immediately I'm going to write distance equals the square root of x2. We'll say 7, or negative 3 is our x2. So we'll go negative 3 minus our x1. We'll call 3.5. So 3.5 squared plus our y2. Since we chose negative 3 as our x2, that means we got to choose 7 as our y2. So 7 minus our y1, which is going to be 0.5, all squared. Okay, now let's simplify. Take the square root. Negative 3 minus 3.5 is negative 6.5. Then we got to square that. Plus 7 minus 0.5 is 6.5, and then we got to square that as well. Okay, and what's beautiful about this is no matter if the number you get here, like the negative 6.5 or 6.5 is negative or positive, they're always going to end up being positive in the end because you're always going to have to square the numbers. So we're just going to do 6.5 squared, or 6.5 times 6.5, and that's going to equal 42.25. Okay, and then of course we're going to add that to our other 6.5, so that'll also be 42.25. And then we're going to add both of those numbers together under the square root. 42.25 plus 42.25 is going to equal 84.5. And then we just got to take the square root of 84.5. So you can get your calculators out because it's not quite straightforward. So we do the square root of 84.5. And that is going to be equal to 9.19. Now it says round to the 10th place, so that's just our first number. And since 9 is greater than 5, we're going to round that to 9.2. And that is finally going to be our distance. And there it is after all that work, okay? I'm going to stop the video there because all the examples after that are basically the same thing. So just follow the same process for each one. I'll catch you on the next IXL tutorial video. Goodbye.